Hello everyone. On today's episode of Tinkering with Terrius, we're going to be working on the PIR project again. Previously we had been assembling the PIR project on these white prototype boards. I've been having some issues with these white prototype boards and having the connections too loose, and it was causing all sorts of problems with the power distribution from the power board. So in an attempt to fix that, I've assembled it onto a prototype board. We have the LT1073 in a socket. We have some female headers for the components, and we have some male headers for the outputs and the inputs. What we're going to hopefully see is that this makes it much more stable coming out of the chip, and that it'll be able to run the LEDs without any problems. If it is working properly, then what we'll do is we will put it onto a permanent prototype board, which is going to be this little board. This one has a bunch of copper pads that are connected together, which will make connecting the chip up a lot easier. So hopefully this will work just fine and we'll be able to move on with the project. So we've got our multimeter here just to check and make sure the voltages are going to be working. So with everything connected here, we're getting 4.92 volts on the output from the 1.5 volt input, which is a good sign. So now the next thing we have to do is test it with the LEDs, drawing about 30 milliamps, which is perfect. This is exactly what we want. It's lighting those LEDs up almost completely. Means it's about 15 milliamp going into each of the two banks, and those should be plenty bright enough. Let's see. I'm going to turn off the lights here. How bright that is. That's quite substantial. I think those LEDs are going to be just bright enough. Now the other thing I wanted to try out was swapping these red ones out for the orange ones. They're substantially dimmer. I don't think you'd be able to see them at all. So I think we're going to end up using the red LEDs. It's still drawing 32 milliamps. I was expecting these to be much brighter, but they're not. So I would assume that these aren't getting quite high enough voltage for what they need. I don't know, even at 3 volts it's quite dim. Yeah, much dimmer than the red one. See that. Just see how much better this red one is doing. So the whole LED bulb is lit up. Orange one's just barely lighting up. So we're definitely going to be using the red ones. Now we're going to assemble the permanent board here. So that's how it's basically gonna be, hopefully, once we're done here. The input's on this side, the output on that side, and then the removable components. Okay, so we have the board assembled here. We have the socket here. We have the feedback pin running on this side with a little white wire under the socket and then down to where it's supposed to connect, which is important because if you forget to put in this feedback pin, the output voltage goes up to like 50 volts and it's ridiculous. So make sure you connect that pin. And then on the bottom here we have all of the connections made, solid connections compared to the other prototype boards. Now let's put the components in and hopefully see if it works. Because if not, that would have been a disappointing amount of effort for something non-functioning. This chip does not like to go in anymore because it's been taken out of too many chip holders. Okay, there we go. LT1073 is installed. Next we have the inductor. Put that in. Connects those two pins. And the diode. It's also important to make sure the diode is in the correct direction because if not, nothing will happen. Of course, makes sense. And same with the capacitor, which is why this is handy because the negative is all by itself. It's easy to remember which is positive and negative. So on this board now, you can't really see it because it's too shadowy. This is the positive side. Everything on this side of the circuit board is positive. Everything on this side of the circuit board is negative. We're using the common bus here as the negative rail that connects all of the negatives together. And on this side we have the positive rail, but it breaks right here. It's on the positive rail here, as you can see. That's how it works. And now we're going to connect the battery. So we're going to connect the positive battery terminal and the negative. And boom, 4.9 something volts. Woohoo! So it's definitely working. Voltage isn't randomly dropping out, which is what I was having even on this board. I was having the voltage randomly drop out because the leads I was connecting to it were not solid enough. So that's why we have these triple or quadruple leads. They're much sturdier. And now we can test this again and see if it lights the LEDs. I'm pretty sure I have these hooked up wrong. I don't think I have them hooked up in pairs right now, but it's drawing 54 milliamps. And I think this board is going to work very well. Seems a lot less shaky in the output here, which is very good, and that's what we were hoping for. So that's about it for this episode of Tinkering with Terrius. I hope you enjoyed it. If you did enjoy this episode, then be sure to give it a thumbs up. In our next episode, we'll probably assemble the rest of the circuit and get everything together and make sure it works. If you have any questions or comments, feel free to leave them in the section below. If you feel like sharing this video, then please do. If you haven't subscribed to my channel already, then be sure to hit the big Tinkering with Terrius sign in the middle of the screen here. Thank you for watching. I hope you have a wonderful day.